Welcome back. So in this video, I'm going to work out a couple practice problems for you so you can see it in effect. I got these straight out of your textbook, as you can see in the supplemental practice problems of section 4 in chapter 14. So this would be a standard way you would see a colligative property question asked. We'll work number 1, and then number 2 you're going to try on yourself and then come back. So number 1, calculate the freezing point and boiling point of a solution containing 6.42 grams of sucrose. They give you the chemical formula there, in 100 grams of water. Okay, so they're not going to ask us here for the change in temperature. And remember, that's what our formula is. Oops. Our formula is delta T equals KMN. They're not asking us for the change in temperature. They're asking us for the brand new freezing point or boiling point. So what you're going to do is you're going to calculate your delta T, and then you're going to use that change to alter the boiling point or freezing point. So when we're dealing with water, this boiling point and freezing point you must have memorized. So water's boiling point equals 100 degrees Celsius, and its freezing point equals 0 degrees Celsius. I think most of you already have that memorized, but just in case. So let's look at first the freezing point, right? So this is number 1 we're going to work. Delta TF, right, for freezing point change, equals KF MN. Well, we need to find out a few of these things. So I'm going to do a Google search for the freezing constant of water. You'll always be given these. It is a negative 1.86. Now we need to find the molality. How do we calculate molality? Well, we have to find the moles of solute. The solute is our sucrose in our kilograms of water. So we've got 100 grams. This equals 0.1 kilograms. So our molality, therefore, we got to find our moles. 6.42 grams of sucrose. 1 mole of sucrose, we have to add up the molar masses. That means carbon is 12. We have 12 times 12 plus 22 hydrogens, which is just a 1, plus 11 times 16 for oxygen. So we get a molar mass of 342 grams. So 6.42 divided by 342 gives us the moles of 0.0188. So we take our 0.0188, we divide it by our 0.1 kilograms for a molality of 0.188. So we put that in here for M. And now we have to decide how many particles does our solute dissolve into. Well, if you notice, this is an organic solute. It's carbon-based. It's covalently bonded. Anytime you have carbon, hydrogen, and oxygen, you're having covalent bonds. So therefore, this only dissolves into 1 particle. So instead of breaking it up into ions or atoms, you have each molecule floating around in your solution. So our N is just going to be a 1. Calculate this out, and you get that our change in freezing point is going to be, a negative 0.350 degrees Celsius. What that means is, remember, freezing point is always lowered when you add a solute in. That's why the negative number. So you're going to take your freezing point, which is 0 degrees. Now for other solvents, it's going to be a different temperature because everything boils and freezes at difference. But because our solvent was water, that's why we start with 0. And we're going to minus our 0.350 degrees. So our new freezing point is a negative 0.350 degrees Celsius. Well, now let's find our boiling point. Well, our delta T for boiling is going to be our boiling point constant times our molality times our number of particles. Now the nice thing here, the boiling point constant is different. The boiling point constant is 0.52. But have we changed our molality? No, that's still 0.188 molal. And we haven't changed the number of particles. So that's just a 1. So now when you calculate your change in boiling point, you get 0.52 times 0.188 equals a 0.0978 degrees Celsius. So now for your new boiling point, you will take the original boiling point of your solvent and add your change. So this becomes this. Well, if we adjust for significant digits, notice we've got to go to 3 significant digits because of our original problem. 3 significant digits is still going to be 100 degrees Celsius. This amount of sugar dissolved in the water doesn't change the boiling point enough. Something to keep in mind. All right, so that's how you would do it. Now, I want you to stop this video. I want you to go ahead and work out number 2 and then come back and check your answers. Okay, well, I hope you did pause the video, and as you can see, I've worked out number 2 completely from start to finish so that we can just go through and talk about the answer. So hopefully the first thing you noticed was right here that 250 grams is our solvent, so we need that in kilograms, which is equal to 0.25 kilograms. We then have to take our copper sulfate, and here is your formula for copper sulfate. We need to take that and convert it to moles. When you do that, you divide by the molar mass, you get 0.149 moles. You use that and your kilograms of solvent in your molality equation, and you will get 0.594 molal solution of copper sulfate. We use this into our delta T formula. Since our solvent is water, I've taken our Kf for water, which is negative 1.86. I've multiplied it by our molality. And then here for our number of particles, I've used the number 2. This is because copper sulfate is ionic. You know this because copper is a metal and sulfate is a polyatomic ion. So copper is one of your ions, sulfate is your other ion. When I multiply this together, I get a negative 2.21 degrees. I subtract that from 0, and my new freezing point is negative 2.21 degrees Celsius. To find our new boiling point, all I do is use my Kb plus my times my molality times the number of particles. And when I do that, I get that my change in boiling point is a 0.618. I add that to my original boiling point of 100 degrees, and I get 100.618 degrees Celsius. Well, I need to adjust for significant digits, which is 3 significant digits. When I do that, I get an answer of approximately 101 degrees Celsius. Hope that helped you in figuring out how to do colligative property calculations. Go on and do your assignment. If you need any help, come see me in Zoom. Have a great day. I'll see you later.